graph, right? Okay, let's start. The reason why I skip chapter 1 at first is because once you learn chapter 2, then you are familiar with the acceleration, you are familiar with the velocity, you are familiar with the momentum. Then when you go back, then you will be more, you catch up more easily, especially when we talk about the unit. Because at first, 如果我一来直接从 chapter 1 start， 你会有点 blur， 因为你有那种 acceleration， 那种全部是新的 term， 我们不知道，还没有学。That's why 现在我们回去 ，OK， 我们回去，然后我们看全部 physical quantity and the unit, right? Now, how do you define physical quantity? Very simple, short answer. What is physical quantity? Anything that can be measured. Can you measure happiness? You cannot measure happiness. So is happiness a physical quantity? Not a physical quantity. Can you measure motivation? You cannot measure motivation. So is motivation a physical quantity? No. So physical quantity must be something that you can measure. For example, time, length, okay, all these things you know. All these things I can measure, I can give it a unit. I will call them physical quantity. Now, the main thing, the two main big category, you have your base, right? You have your base quantity. I will create a table. Base quantity. Versus what? Derived quantity. Write it here. Derived quantity. What is base and what is derived? Base is like the quantity that cannot be broken down into simpler, right? For example, like, let's say I take one example like H2O. H2O made of oxygen and hydrogen. Until oxygen, can you break down even simpler? No, right? Until this is the simplest form. This is the simplest form. These two simplest forms combined become a larger molecule. It becomes the derived quantity. This is the derived. This is the base. Okay, so base is something that is at the simplest. It cannot be broken down any further. That is like the base, the fundamental. And then I can combine the base to make another unit, to make another element. That is the derived. So derived, all of the derived you get from where? You get from base. All of the derived you get from base. Okay, so let's go through the base quantity. What are the common ones? All these you need to remember, right? The first one, now mass. We will create a table like this. First, we will do the quantity, and then we will do a symbol, and then we do unit and unit symbol. We do the base first, then later we'll go to the derived, everything, okay? Now, here, the base quantity, the first one is going to be the mass. Symbol, take the first letter, okay? M. Now, unit, we use what? SI is SI unit, kilogram. Okay, kilogram. And then unit symbol, so the symbol of the unit is going to be kg. Second one, what else? Length. Symbol, L. SI unit, meter. Unit symbol, okay, so M. Be careful with the unit symbol and the symbol for the physical quantity. This one stands for the mass, this one stands for the unit. How do you know this one is whether it is the unit of length or whether it is mass. How do you know? You see there must be a number in front. If I write 30M followed by a number, what is followed by a number? A unit is followed by a number. So if you have a unit, if you have a number here, then this must be meter. Okay, please don't go and say, oh, this is the mass. No. Okay, you must have a number and a unit. All right. So length, L, meter, M. Now, then we go temperature. Okay, temperature symbol, capital T, SI unit. This is in Kelvin. Okay, and this one is capital K. All right, 1, 2, 3. We got another 2. Time. Time is small t, second. S. And the last one. Actually, you have many more. These are just the 5 you need. The 5 that will be asked commonly. There are more actually. Okay, current. Current is what? Current is a special one. We do not use C. The symbol, we do not use C, we use I. Okay, I, what is the SI unit? This is ampere. Ampere then is capital A. Okay, so here are my 5. Can you give some more? Is there any extra? Can you think of any extra base quantity? Like something that cannot be broken down into other. Like for example, mass is just mass. You cannot use length. Let's say if I say area, area is length times length, right? So area, basically you get area from length because length times length, right? But mass, where you get mass from? You get mass from mass, no other. Length, where you get it from? You get it from length also. There's no other replacement. So these are the base. Okay, so there's one more. Okay, you can put angle. Angle is also, right? Angle. Can angle be expressed as other quantity? No, angle is just angle. Okay, but we do not put it here. I mean, it will not be asked here. Okay, so the list can go many. The list can go on and on. Okay, but these are the 5. Now, let's move to this one. And this is the main focus today. Derived quantity. All right. Here again, we will create a table. Okay, you can do the same with me. You can do the same, and then you write down all the unit later. Okay, I know the books already got it, but here we are doing something different. Okay, you want to take it down. I know your textbook already got all this. Right, so let's do derived quantity. This is the symbol. And this is the, this column here, we will do in terms of base quantity. In terms of base quantity. Can see, yeah? Okay, can see. In terms of base quantity. And then this one we will do in terms of SI unit. And then this one we will do specific units. Specific units like, for example, like Newton, what else? Newton and Joule, all this. Okay, the special one. Okay, so 4 column, 5 column, sorry. Okay, now let's put in the values here. Maybe I make this one bigger a bit, sorry. I increase the space for this one because I'm going to need a bit space here. Okay, first one. Area, symbol A. Now, in terms of base quantity, this one, most of the question they will ask this one. Meaning that for the derived quantity, they want you to give what makes this one. Okay, the base. This has to be the base. So for example, if you put force here, cannot, because force is a derived quantity, right? All this column must be all this, a combination of all this. You cannot have other quantity other than this. This one has to be from all here, right? So area is length, right? Length, okay, L, I just put L times L here, L times L. Then in terms of SI base unit, that means we are going to convert this one, we want to get the unit. Whose unit is this? This unit is the unit of area. Unit of area, but the unit is in terms of base unit, all this. Okay, so all this unit is in terms of this one here. Okay, so how do we do this? We just change this one. Length, this one we change to meter, right? So the unit for length, meter, okay, meter. This one you times together, you get m squared, right? So that m squared is the unit of area in terms of base unit. Okay, so again, when I say base unit here, SI base unit, it means this one must be from here. Now, next one, volume. V, okay, length times length times length. Here I change m times m, get m cubed. Is there any special unit? No, so m squared and m cubed. Right, let's do density. This is like a P, right? This, how do you pronounce this? This is pronounced as rho, R-H-O. The symbol looks like a P, pronounced as rho. Okay, rho, and density is, we know is mass over volume, right? Okay, mass over volume. But volume 是 base 吗 ？volume 不是 base 啊 ，volume 是这边吗？对不对？这个是 derived， 所以你这边不可以放 volume， 因为我这边叫 in terms of base quantity， 所以我要 break down 这个 volume，I want to break it down， I get something like m over length times length times length. All this length is from here, so I put that there. Okay, so here what I write in terms of SI base, then I only change this to unit. Okay, so the mass is going to be kg, and then m times m equals to kg over m cube, right? kg over m cube 这个你要怎样写？你可以这样子写，或者你可以写 kg/m cube。OK， 一样的东西 kg over m cube， 或者你可以写 kg m 减3。Okay, what is this? M minus 3 is 1 over m over 3. Okay, so just change the minus to 1 over. You just remove this one, become 1 over, and then the rest is the same. 1 over 3. Okay. Specific unit? No. Now, velocity. Oh, we cannot see here. Velocity. Velocity V. Sometimes they use U, right? And okay, quantity. Now, velocity is displacement over time. Displacement is what? Displacement is a measure of length. Okay, length over time. Is this base? Yes, they are the base, right? So L over T. So here I write here. M over S. So it's M meter per second velocity. Okay, getting more and more complicated. Acceleration. Acceleration A. Acceleration the formula is what? Final velocity 减 initial velocity over time, 对吗? Right? So acceleration is final velocity minus initial velocity over time. So here on top is minus, right? But I'm still minusing the velocity with another velocity. So in the end, it is still velocity. It's still velocity, so I just write it like this: V over T. Right? It doesn't change anything. Huh? Velocity minus velocity, you still get velocity here. Okay? But we don't want the velocity to be in here. Again, we want the base quantity. So I want to break down the velocity. This velocity equals to what? From the previous one, length over time. So I'm going to put this one. We have length over time on top, right? Divide T. So divide T. Divide T, I'm going to write it as length over T times 1 over T. Okay, numerator with numerator, denominator with denominator. So you get L over T squared. This is the acceleration in terms of base quantity. How will they ask you? They say, okay, A, B, C, D, pick the one that represent acceleration. This is what? This is length over time squared. Acceleration is length over time squared. OK 啊，全部是 base unit. Now， 现在我要找它的 unit， 我直接把这个换去 unit。Length over time squared. Length 是 meter over second squared. Meter per second squared. That's how you get the acceleration. Okay, next one. Force. What is in terms of base quantity? Force is made of what? Force is made of F equals to ma, right? F equals to ma. This is my formula. Okay, this is the general formula for force. Mass times acceleration. Okay. Mass acceleration. Mass 是 base 吗 ？Mass 是 base。acceleration 是 base 吗 ？acceleration 不是 base。所以我要把这个拆上。acceleration 它是什么？我们看之前的 acceleration 是 length over time square， 所以我会换这个等于 m 乘 length over time square， 这个是等于 ml over t square。Okay, so force 你可以写成 mass 乘 length over time square。这个是我 express 在 base unit. Okay, so what is the unit? The unit I just changed this to kg, mass kg. length times meter t square second square。这个讲 kg 乘 m kgm， 然后 slash s square right， 所以这个我可以把它写成 slash s square 是什么 ？OK， 这边 s square one over s square 嘛，对不对 ？one over s square 这个，所以我这个把它变成 s 减2，意思说这个变成 kg m s 减2。This one is more famous than the rest lah. Sometimes they will ask this. Most of the time, the force unit kg ms minus 2. What is the force unit that you learn? Newton, right? Newton. This is the specific unit, Newton. If the question asks you, what is the base unit? What is the base SI base unit of force? You cannot give this one, huh? Wrong, huh? You have to give what? You have to give this one. You have to give kg ms minus 2. Momentum. Now you should know momentum. Formula is T equals to mv, right? mv. Okay, this is a base. This is not a base. Break this. What is v? V is L over T. Okay, so this is ml over m times L over T. ml over T. This is momentum. Okay, unit m kg times meter over second. So this is kg 乘你直接 combine kgm， 然后除 second 嘛，对不对 ？1 over second， so this is second minus 1. kgms minus 1. This is the unit for momentum. Okay, now next one. I put pressure. There are some quantity maybe we haven't learned yet, but most of it we know, right? This one, we know this. This one, have we learned pressure? Not really, right? Not really. We haven't learned that much about pressure. But if I tell you the equation, you will be able to find the base. Yes, okay. Edmund said, oh, you learn it. Okay, some of you may have learned it, right? F over A, yes. P F over A. Okay, do we have enough space? Okay. F is MA over area. I break it down again, L times L. Okay, the A, you have to break it. The A, M, what is A? L over T. Okay, ML over T square divided by L square. Okay, you can see ML over T square. Okay, this one I will write it ML over T square times 1 over L square. Okay. This one I cut. This one 1 equals to M over LT square. Right? Even though the equation you're not familiar, it can be other equation. You still can break it down, right? So break it down this one, then you find the unit. Okay, this is kg over what? Meter times into second square. This one, what is this? Kg over ms minus 2. This one I can write it as, this is like kg times 1 over ms2, right? So I can write it as kg m minus 1 s minus 2. Don't forget the 1 over is for the m and the s also. So 1 over m is m minus 1. 1 over s squared is s minus 2. All right. So this is base unit for pressure. And here, specific unit, Pascal. PA. Okay, so make sure you take down this one. And no need to memorize that. This one is like the step to just find it. Okay. Take down this one, and I already erased this one. I want to erase the field because I still got like a bit 3 to 4. Okay. Let's get some space here. All right. Energy. Energy is same as work. Work done. Okay. Energy symbol, it can be E or it can be W, capital W. W stands for work. This is the next chapter after the force and motion. Okay, now in terms of base quantity, I give you the formula. W is force times D. Okay, force into distance. Is this the base? This is not base, so you have to break it down. This is MA times D. The D is distance, it is length. So I change this to L. MAL. Okay. What is our A? A is L over T squared. M times L over T squared times L. All this we combine, ML squared over T squared. Unit kg m squared over second squared. This one I can write it as kg m squared 1 over s2, s minus 2. What is the specific unit? Joule. Okay. Two more. Power. Symbol P capital. Same as pressure. Capital P. Right. Power is equals to energy over time. Okay, so very simple. You just take whatever here, divide by time. So ml square t square divide by time, so it's multiply 1 over time. So ml square over t cube, right? Okay. This one will be kg m square s minus 3. Specific unit? What? W. ATT, capital W. Okay, so last one. I will erase this. Acceleration, okay, let's write down this one because this is like linked to many, right? Acceleration is linked to many. L over t squared. I'll just write it here. Okay. Weight, capital W. Weight, W, what is the formula? W equals mg. Okay, what is the g? The g is gravitational acceleration. So it's the same as ma. Okay, a is L over t squared, ml over t squared. Mass length over time squared. Okay, so kg times m over second squared. kg ms 减2，这个跟什么一样 ？kgms 减2，这个跟我们的 force 一样，对吗 ？force，因为 weight 就是 force 嘛 ，weight is force。Okay, so same this one, same here. I will write Newton. Now, let's look at one example. Given Hooke's law F equals to kx, where x is the extension, find the unit of constant k. Okay, so constant 是什么 ？constant 是好像一个 fixed value 啊，就很像 pi 啊。Pi is 3.142. It's a fixed value and it remains the same, it remains true everywhere. It is universal. It's a universal, okay? So constant k, it's like just a value, fixed value, okay? Now we want to find the unit of constant. So how do we find it? Given any equation, right, we can find the unit. First, we have to make the k in the y-axis. So I want to make like this. K equals to f over x. I will put the k, the one that I want to find, in the y-axis like this, and then I can find this one is Newton. X, what is the x? X is extension, right? Extension is measured in length. So here will be meter. Newton, meter. So Newton's meter minus 1. This is 1 unit. I can put like this, Newton meter minus 1. Let's say the question wants you to find. Find the unit of K in terms of SI base unit. What do you have to do? Is this base unit? You have a Newton here. Newton is not a base unit. Newton is a derived. So you have to change this one. So if the question says find the unit of K in terms of SI base unit, then we will do K equals to F equals to MA over X. X is just length. I will change this to L. Okay, now same thing, your acceleration, A equals to L over T squared. That is in terms of the base. Okay, so here, M over L times A equals to L over T squared. Cancel, cancel. M over T squared. Okay, so M, this is kg. This is second squared. Second squared, kg over second squared equals to kg second minus 2. That is my answer. Okay, so here, from here to here, M over L times A. Okay, then to this step. This one finish, huh? Okay, find the unit of K. Now, here, E, 2E, 2E, what is the unit? Unit of energy is joule. You times 2, it is still joule, doesn't change anything. So here, we do not care about the constant. I mean the value 2. 2E is still joule, so I will write here joule over M2, Jm minus 2. What about this one? Energy equals to F distance length squared. Force is MA, distance is L. 2 M A L squared. Acceleration over here, right? Again, I want to break this. Acceleration is L over T squared. So here I will change L over T squared. Okay, so let me get some space here. Two ML squared. Here, L squared over T squared. Yeah, so times 1 over L squared. Two M over T squared. Two M kg, right? So 2 times kg is still kg. So kg over second squared. kgs minus 2. This is my answer. 如果我写 let's say 我写 mass A 减 mass B，let's say 我有 K 啊 ，K 等于 mass A 减 mass B over T。我的 unit 是什么 ？mass A，mass 是 kg 对吗 ？mass 是 kg，mass B 也是 kg，T 是 second。kg 减 kg，你的 unit 还是 kg。2 kg 减1 kg，1 kg，你的 unit 没有变的，还是一样 kg over second。可是如果我写这里是乘 ma 乘 mb，OK， 这样你的 kg 就会变 kg square over second。So 加跟减不会影响你的 unit， 乘跟除 ，OK， 它会影响你的 unit。This is for especially for finding the unit of a constant. Given any equation, you can find the constant first by expressing the y-axis, and then you find it. Okay, now I will send you a worksheet in the group. We'll do a little bit of exercise first, then I think about the last 40 or 30 minutes, I will cover the graph part. Still sending, almost sent. Internet is a bit slower. Okay, already sent. Now, not all you do. Only a few questions. I will write it on the board. Okay, you do the questions that I write on the board, right? Not all questions you want to do, because there are some questions that are the prefixes, okay, which I think it will not be covered in the exam. Okay, the unit conversion, the prefixes. So I will write the selective one, which is the unit and derived base and derived quantity here. So you only do these questions on the board. Question 4, 7, 10, 11, 12, 13. If you have any question you want to discuss, just let me know in the chat. D sub here, this one. Which expression does not result in a derived quantity having a unit that is the same as momentum? A unit that is the same as momentum. You see, A is force times time, right? A is force times time. The unit is Newton second. B is mass velocity. mv. Okay, this is the same kg ms minus 1. Newton second is also the same unit as momentum, right? Newton second. Where you get this one? This is from the impulse, right? Impulse I is the change in momentum mv 减 mu， 这个是 change in momentum 跟 impulse 是一样的 ，OK？ 所以 momentum 有时候我可以写 kg ms 减1，有时候我可以写 ns。So A is correct. A is correct. That means answer is C lah. Answer is C lah. C is not the same as momentum. Okay, for question 31. Given the formula, force equals to C times speed squared. Find the unit of C. Okay, same thing. You want to find the unit of the C, so we make C equals to force over V squared. Question 1, base unit, right? Base unit. So force, the base unit is what? kg ms minus 2. Divided by V squared. V squared, okay? The V squared is given in the here, ms minus 1, and then you have to square this. Then you have to square this. Now, equals to kg ms minus 2 over this one, 2. How do you multiply in? This one multiply to 2. You got an m, you got an s, so the m will be square, and the s will be minus 2. Okay. So here we cancel. Cancel, this one, cancel 1 equals to kg over m in base unit. (11) The unit of measure for pressure volume are, okay, basically it says PV, right? PV is equivalent to the unit of what? Okay, let's find out what is the unit of PV. P is what? Nm minus 2, so that's N over M2 times, and the V is M cubed, right? Okay, this one cut, this one become 1. So I got Nm. Which one is similar to Nm? Let's see force. Is force Nm? Force is just N, right? That's force. What about power? Power is what? W. And if you look at work, work is force times distance. The formula of work is force times distance. So that is Newton. Newton into meter. Same as this one. Answer is A.那种比较常用到的，你可以记起来了，就是这样。kgms 减2，这个你可以记起来，这个是 force 的。怎样都会 relate 到 force，acceleration 也是 ms minus 2或者 L over T squared。OK， 因为如果他突然间问到 force， 他问这个 C， 如果你从 force 就开始找，所谓太吃时间，所以如果你记到 force 啊，这样就 OK。That's this one. The rest you can derive yourself. Okay, 10 more minutes. I will talk a little bit about the graph. The answer already sent. 28. Pressure is a derived quantity. This quantity can be expressed as pressure is force over area. Okay, force over area F 是什么 ？ma area 是 L square。acceleration 是 m length over t square over L square. Right, that's why I can put it in. So ml over t square divided by L square. This one is okay, get this one. What is this? Mass over length times square. 意思说这个是 mass 等于 length times time and time. OK， 这个拿下来了吗？我擦掉这个。 Okay, now put a 3 in the chat if you're still behind the screen. Put a 3 in the chat if you're still behind the screen. Andrew, Daryl, Jasmine, Vanessa. Okay. Edmund and Noel, are you there? Put a 3 in the chat if you are behind the screen. Okay, right. Okay, we still have half an hour. I want to kind of cover a little bit more. What it means to have a directly proportional graph. If I give two variables, y, x, you know the directly proportional graph. If I say that these two are directly proportional, that means you will get a straight line that cuts the origin. If this one is not from the origin, somewhere here, it is not directly proportional. So this is a directly proportional graph. And what does that mean to be directly proportional? Let's say I put some values in. 2, 4, 6, 8. 1, 2, 3, 4. Here, from here, we see if I go from here to here, plus 1. Yes, I see some answers. X increases, Y increases, correct. But if I want to make it complete, X increases as Y increases, and I will say that they increase at the same rate. This one plus 1, this one plus 2. This one not necessarily has to be plus 1. But here, if I plus another 1, then this one same, plus 2. It remains the same changes. Again, I go up here, plus 1. This one go here, plus 2. These go, keeps on going, keeps on plus 2, plus 2, plus 2, plus 2. So here we say for every 1 unit, increment in the Y, for every 1 unit increment of Y, X changes the same amount. X changes the same amount. Plus 2, plus 2, plus 2. It will not suddenly go like plus 2, plus 2, plus 6, plus 8. Okay? So in that case, if you plus 2, plus 2, plus 6, plus 8, plus 13, then you will get a curved graph. That is no longer proportional, right? So that is the meaning of proportional. The true meaning of proportional graph is that for every unit increment of a variable, can be X, can be Y, the other unit changes the same amount. Okay, so how much is the change amount? You can calculate it using the gradient, right? So here I pick a point, here I pick a point, I draw here this one. Okay, what is this? This one is 4 minus 2, 2. This one, 8 minus 4, 4. Okay, so this is my Y, this is my X. Gradient Y over X. 204, 1/2, 0.5. What does this mean? 0.5. This means 你在除什么？你除 y 除以 x 对吗？你除的那个东西啊，在那个分母，它是永远是那个 1 unit。一说你现在是在找着 for 1 unit increment of x, y changes this much。你在除 x 啊，一说你在把这个变去 1 unit。OK， 你除的那个永远是变去1 unit， 那个分母啊，分母是变1，所以我现在是在找这，真正我在找 gradient 呢，我是在找 for 1 unit increment of x, y changes how much? 0.5. So 1 unit of x, y changes 0.5. How about 2 unit of x? 1 unit of x, y changes 0.5. 2 unit of x, y changes by 1. So here, 2 unit of x, y changes by 1. 2 unit of x, y changes by 1. Same here, every 2 unit, y changes by 1. It must be the same 0.5. It doesn't change. So here, we will say, this is a directly proportional graph. Okay, so the gradient, what happened to the gradient? It is a constant gradient. Constant at 0.5. Here, doesn't change. So a straight line, remember, a straight line has a constant gradient. This one you're already familiar because you have learned the motion graph. Right? Here, gradient is the same over here. Gradient is the same. Why the gradient is the same? Because the changes must be the same. Okay, every increment, same increment. But if you have a curve, then the changes is not the same anymore. This is like the thermometer, 就很像你的那个 thermometer， 你量温度这样子。Let's say 这边是100 cm. Okay, so you got 100 degree Celsius. This is 0 degree Celsius. When it rises 1 degree, how much the heat, how much the mercury inside rises? Okay, the mercury inside rises 1 cm. You rise another 1 degree, this one rises another 1 cm. You rise another 1 degree, this one rises another 1 cm. So you rise 100 degree, this one rises 100 degree. The change is the same. This one changed by 1, this one changed by 1, changed by 1, changed by 1. Here, if you go from 1 degree, this one will not suddenly go 5. 1 degree, here 5 cm. That is what happened. In that case, it is not proportional, right? Not proportional. So here, we say what? We say that the temperature and the length are proportional. Because for every changes, this is the same, right? Okay, so the temperature and length are proportional. Yeah, y is proportional to x. Okay, so we use a symbol. We use a symbol says what? Y like this, like an alpha. Okay, like alpha, and then x. This one stays y is directly proportional. Okay, you already know this one. Y is directly proportional to x like this. Now, what if I give you this? This is the inverse of x, 1 over. So if I plot the graph of y against x, if I plot the graph of y against x, what you get? Here, you will get like a inversely proportional. How does inversely proportional look like? It's a curve, huh? It's a curve down like this. Because you can see here, when x is, let's say, 10, when x is 10, what is your value of your y? Y equals to 1 over x, right? When x is 10, x, okay, I write like this. X is 10, y equals to 1 over 10, 0.1. When x is 100, y equals to 1 over 100, 0.01. When x is 1000, y equals to 1 over 1000, 0.001. When the x increase, the y, what happened? 0.1, 0.001, 0.0001. Decreasing. So when I increase the x, 10, 100, 1000, what I get here? 0.1. Here, 0.01. Here, 0.001. This is a curved graph. Like this. Okay, so that is inversely proportional. This one keeps on going, okay, never touches this one. Keeps on, go very near like this. Very near. It keeps on, we say that it keeps on approaching. Meaning that approaching is like go near, right? It keeps on approaching the axis, but never cut the axis. That is by inversely proportional. So this is this one. Y is inversely proportional to what? Very important, huh? To what? To x or to 1 over x? To x, huh? To x. I can also say this one. I can also say this one as y is directly proportional to 1 over x. Right? This one, y, how do you read this? Y is proportional to x. This one, y is proportional to 1 over x. So this is also correct. Y is directly proportional to 1 over x. This is also correct. Y is inversely proportional to x. So what does it mean? That means if I plot the graph y against 1 over x, what is my graph for this one? My graph is going to look like this because y is proportional to 1 over x. If I plot 1 over x, I will get a directly proportional graph. If I plot only x, I will get an inversely proportional graph. Okay? Now, example of questions, how they will ask you like this. Let me erase this first. If you can 把它弄去 straight line， 意思说你可以用 y equals to mx 加 c。OK， 如果你可以弄到它边去这一个 form，then 你就可以 plot 一个 straight line。什么意思？好 ，let's say 我们拿一个 example。Example one， 我给你一个 equation s 减 mr 等于 n。And then I ask you plot R versus N. What is the gradient? Plot R versus N, R against N. What is the gradient? Okay, so that means our graph is going to look like R, now N 在这边，对吗 ？Okay, R against N 啊 ，so Rn. Now 从这个 equation S 减 mr 减 n， 我先弄我的 y 等于 mx 加 c， 我的 y 是 R， 我的 x 是 n， 所以我要先 arrange 我的 equation。 我把 y 放在 left hand side， 就是说我的 left hand side 一定要是 r， 我把 r 留在 left hand side， 其他的我搬过去对面。OK， 因为我要 make sure 我这个转换成这一个 format。OK 啊，我转这个去我的这一个 format。OK， here 减 mr 等于 n 减 s。OK， 我乘减，所以这边是 mr 等于减 n 加 s。Oops， 看不到啊，我写下面一点啊 ，mr 减 n 加 s。OK， 这个我把它写成 s 减 n 咯 ，s 减 n。现在我把 m 搬过去 ，OK，r 等于 s 减 n over m， 我可以把它写成 s over m 减 n over m。我可以 compare 吗？这边它这个是在 y 等于 mx 加 c format， 我还可以用这个 r 等于这个我移位置减 n over m 加 s over m。Okay, I change the place here. The last step, see the x should be n, right? So I'm going to put the n like this. 1 over m, n plus s over m. Okay? So, put like this. Y equals to mx plus c. Like this. So what is my gradient? What is the gradient here? The gradient m is equals to minus 1 over m. Okay? Right. 所以如果你要找 gradient 或者 even they ask the y-intercept, sometimes they ask this one. Okay, that's y-intercept is s over m. That means that using this graph, 因为我已经把它变成 y 等于 mx 加 c， 所以我可以 plot 一个 straight line graph， plot 一个 straight line graph， r against n。 OK， 我的 y axis 是 r， 我的 x axis n， 然后我的 y-intercept 是 s over m。 I just label somewhere here s over m。 然后我的 line 就是什么 line？ y equals to mx 加 c 对吗？ straight line 哦 straight line。 So gradient is what? The gradient is minus 1 over, okay, this one should be minus. I made a mistake. I will correct this one. Gradient is a minus. 1 over m. So maybe like this. S over m, the gradient, minus 1 over m. Okay, now let's say what? We'll plot m versus n, find the gradient. M versus n， 就说现在是我的 y axis 跟 x axis 变了啊，这个是我的 y， 这个是我的 x。所以当我弄去 y 等于 mx 加 c 的时候，我这个一定要是 m， 我这个 x 要 n。OK， 所以我们先拿回一样的 equation，s 减 mr 等于 n。我要我的 y， 也就是我的 m 在左手边，对吗？所以我把 m 留下来，其他的搬过去，减 mr 等于 n 减 s。OK， 减把拿走 mr 等于 s 减 n， 把 m 留下来 ，r 搬过去 ，m 等于 s over r 减 n over r。搬过去了，然后我的 x， 现在你已经弄了 y 嘛，对不对？你的 x 你要是 n， 所以我的 n 在哪里？我的 n 在这边，我的 n 在后面这边，对吧？这个整个 term 有我的 n， 所以我要把这个移去前面，这个 s over r 我把它搬去后面，所以这边是 m 等于减 n over r 加 s over r。现在差不多了咯 ，x 在这边吗 ？c 是在后面的嘛，对不对？所以 c 是在后面的。focus 你的 x y 不了。那现在我这个我把它拆散，可以把它写成 m 等于减 n， 我把它拿出来就是1 over r 乘 n， 对吗？加 s over r。y equals mx plus c. Y is my m. X is my n. C is my s over r. This is my gradient. So if I plot a graph, m against n, what do I get? A straight line graph. Right? Okay. Now, you go back and you do all the question just now, the ABC. And in the next lesson, we will do the exercises, the test questions. So I will see you again next Tuesday. Right, you can log out.